In this video, we're going to talk about the vector product, more commonly known as the cross product. So this is the other way of multiplying vector by a vector as compared to the dot product from the previous video. So in addition to that, we'll look at the properties and application of the vector product. Okay, so again, let's start with an application in physics to understand what cross product is being used for. So we know in physics that a charged particle moving across a magnetic field will experience a magnetic force. Okay, so according to this diagram, what it means is that if your electron or charged particle is moving in the direction of the green arrow and the magnetic field is in the direction of the blue arrow, then it will experience a force, okay, like this red arrow over here. So the property of this force, okay, the magnitude will be that it is equal to the charge times velocity. Okay, you can simply think of the velocity for now. Okay, so the velocity of the charged particle times the magnetic field strength perpendicular to the velocity. So it has to be perpendicular. Alright, so that's how you can calculate the magnitude of the force. For the direction, we know that the direction of the force will be perpendicular to the velocity and the magnetic field strength. Just like in this diagram, you can see the red arrow is 90 degrees to the blue and 90 degrees to the green arrow. Alright. So the physics way of doing, okay, it's like what we have seen in the previous video. They will try to resolve the blue vector, okay, and take the component that is perpendicular to the green arrow and multiply by the velocity. Okay, so this is what we mean. So we take the magnitude of the velocity times the magnitude of the field strength sine theta. This is basically the perpendicular component as you see here, right? And for the direction, okay, as what we have described earlier, it has to be perpendicular to both V and B. So I will denote it with this vector n hat over here. So you can see that this vector, it is perpendicular to the blue and green, and the hat just means that we treat it as a unit vector so that it is only responsible for the direction, okay, because the length is 1, right, unit vector. Okay, so I can say that the force, okay, which is a vector, it will have a magnitude like this, qv times b times sine theta, and the direction will be n hat, okay, perpendicular to both the velocity and the magnetic field. Alright, so this is the physics way. So for the maths way, we're going to leave out the proof for this, okay, because it requires some kind of linear algebra, okay, but not to worry. We just focus on how we can apply the formula to find the force vector. Okay, so like in the dot product, we will express the velocity vector and the magnetic field vector in terms of a column vector like this. So each element in the vector represents the component in the x direction, y direction, and z direction. Okay, x, y, and z. Okay, and the maths formula says that you can take the velocity vector cross the magnetic field vector. Okay, so how does the cross formula work? It follows like this. Okay, I will describe how you can remember this in the next slide. So basically, the maths way, we make use of the components, okay, and we follow the formula. We can find the force vector, okay, without going to using the physics way, by resolving the force, resolving the magnetic field. We don't have to. Okay, so this is the maths way. Okay, yeah, so this is read as QV cross B. Okay, so how to remember? How we can remember this? Let's say you want to fill in the first element of the new vector, right? So the new vector means it's the first element. The first element, what you can do is you cover the first row like this, okay, and then you take the green component minus the blue component. When I say green component means you take V2 times B3, okay, the blue component will be V3 times B2. Okay, so as you can see here, V2 times B3 minus V3 times B2. Okay, so when you do this calculation, it kind of only tells you the value. Okay, so we actually need to consider the sign also. It can be a plus, it can be a minus. Okay, generally it's easy to remember. The odd terms are usually a plus lah. So basically the sign will keep alternating. So we start from a plus and then minus and then plus. Okay, so hopefully this will help you remember. The sign will alternate. Okay, plus minus then plus. Alright, so let's look at the second element. So the idea follows. To find the second element, okay, what I can do is to cover the second row first, like this. And I do the same thing. I take the green component, the V1 times B3 minus V3 times B1, which is this value over here. Okay, but just take note, okay, because this is the second element, I need to give him the negative sign. Okay, so the value is this, but the sign is a negative. Okay, alright. So for the third element, okay, the idea follows. Okay, I've covered the third row, do the cross product, but make sure that the sign is a positive. Okay, hopefully this helps you remember the cross product formula. Okay, so what we can observe now is that again, because the two method, the physics way and the maths way, they both calculate the magnetic force. Therefore, these two formulas should be equal. So what I can conclude is that this cross product, okay, which according to the maths formula, it gives me a new vector. You can see this is a new vector. This new vector will have the property like this. Okay, property I mean by the magnitude of this vector will be QV, the mod of QB, that means the length of QV, times the length of B times sine theta. This is the magnitude. And the direction will be perpendicular to both V and B. Alright, so this is what we can observe. Okay, so in general, okay, we give you in a more generic sense, like you have two vector, okay, x and y. Then the cross product is defined like this, what we have seen earlier. Okay, this is the formula we have seen just now. You cover the first row and you do the cross product, so on and so forth, right? And this is the maths formula. The physics way says that, okay, it will have a magnitude like this, okay, and the direction will be perpendicular to the x and y, alright? Okay, so this is what I meant. Okay, the red part here tells you that the length of this new vector is just the length of x times the length of y times sine theta. Okay, the blue part here tells you that this new vector, it will be perpendicular to x, because when you dot equals to 0, right, it's perpendicular. Same for the y component, it will be perpendicular to the y vector. Alright, so these are the properties of the cross product. Okay, so compared to what we have seen in the previous video for dot product, so the first property you see here, it's kind of different. In the dot product, we say that it is commutative. That means the sequence of the multiplication doesn't really matter. Okay, but in this case, we realize that it actually matters for cross product. That means U cross V is actually not equals to V cross U. Okay, rather it is equals to the negative version. Okay, the direction actually change when you swap the sequence of multiplying. Okay, so that's the first difference, or I should say the only difference. The other two properties is kind of the same as the dot product. Okay, it is distributive. Okay, you can kind of expand the bracket. You see that? Okay, and same for the constant. If you have a constant multiplied to a vector, okay, you can either factorize out the constant, or you can spread the constant to the second vector. Okay, both is okay, right? Okay, so how we can prove the proving using the maths way is pretty straightforward. Okay, you can just prove from the left hand side, right hand side. Okay, you compare the elements and you realize that indeed the elements is just the negative of the other one, right? You can see the sequence is different, right? So it's a negative of the other one. Okay, but how you can remember using the right hand grid rule, right, is that let's say I'm focusing on A cross B. I want to make sure that my forefingers, okay, excluding the thumb now, the forefingers, when I curl in, it should touch vector A first and then vector B. Okay, so in this example, that means I need to curl in the anti-clockwise direction. You can see. So in this setting, then my thumb will automatically be pointing upwards, right? So this is how you can determine the direction of the cross product. If it's A cross B, you just use your right hand grip move. So if it's the other way around, okay, B cross A, the idea is the same. I want to touch B first and then A. Okay, so in this setting, then I need to make sure my hand points like this. Okay, when I curl, it will be in the clockwise direction, and my thumb will automatically be pointing downwards. Okay, so this is how you can determine the direction of the cross product vector. Okay, so yes, so this kind of proof that the sequence of multiplying matters in cross product. Okay, the difference is that it adds a negative. The direction is different. Okay. So for the distributive property, I'll leave it for you to check. Okay, this is just the brute force formula. Like, just try to expand yourself, rearrange, and you will be able to prove it. Okay, so just remember the property. You can kind of just expand the bracket. Okay, for the constant, multiplying by a constant, again, kind of brute force. Just do your cross product, including the k. Okay, you have a formula that looks like this. So either you can factorize out the k, because now it becomes multiplication in real numbers, right? In real numbers, we know we can factorize. So everything will just look like this. So this proves that we can factorize out the k. And then for the other one, same thing. Okay, because it's just multiplying by a real number in each of the elements here. So I can actually rearrange the k as any way I like, because it's a multiplying of real numbers, right? So I can actually write it like that. So this is for this part here. Okay, so nothing too fanciful. So for the application, okay, we can use it to find the shortest distance from a point to a line. Okay, so we look at the diagram. Okay, so let's say you have a line L here, you have a point A. I want to find the shortest distance. Okay, so let's see how we can find it. So the idea is actually that you make use of a point B on the line, which usually you should be able to find it since you have the equation of the line. And at the same time, because you have the equation of the line, you know the direction of the line. Okay, the direction vector of the line. So in this case, we call it V. V is the direction vector of line L. So what I can do now, okay, let's use simple trigo to figure out how to find the shortest distance. So using trigo, I know that this shortest distance is just the hypotenuse, which is the length of AB, right, times sine theta. Okay, theta is the angle between vector BA and vector V, right? So this will be the trigo way of calculating. But if you remember the formula of the cross product, we know that this is actually hidden in the cross product, right? Because the length of the cross product, it will have this property. It is equal to the length of AB, length of V, times sine theta. Okay, so all we need to do is to take what we want and divide what we don't want over to the other side. So in this case, what we don't want is the length of V, right? We just need the rate term. Okay, so when I rearrange, I'll get this formula over here. So this formula, it's the formula to find the shortest distance of a point A to the line L. Okay, so this is the formula. You can do your cross product, find the length, divide by the length of V. Okay, because you don't need V in a way. You just need AB. Alright. Okay, so for this second application, we can use it to find the area of a triangle enclosed by two vectors. So like this example over here, I want to find this green area, let's say the area of a triangle. So again, using trigo, we know that the formula is half AB sine C, right? So in this case, it will be half the length of vector A, vector B, times sine theta. Theta is the angle between them, okay? And again, we see that this part here, it's kind of hidden in the cross product again. So if I rewrite it in terms of cross product, it will look like this. okay, half times a cross b, okay, and then I take the mod. Okay, that means I only interested in the magnitude of this new vector. Okay, so this value tells me the area of the triangle. Okay, so this is the second application. Yep, and that comes to the end of the video. So make sure now you understand what cross product is. Okay, maybe one way of remembering is that it is used to find the magnetic force of experienced by a charged particle when it passes through a magnetic field. Okay, so some properties. Okay, we have seen this tree. Okay, the first one, it's kind of saying that if you flip the sequence, you introduce a negative. The second is that you can expand the bracket. Third one is that the constant k, you can actually just factorize out. Okay, it doesn't really affect your cross product. And for the application, we have seen two. Okay, to find the shortest distance from a point to a line, area of a triangle bounded by two vectors. Alright, so that is the end of the video. See you in the next video.